Hello, my name is Igor Puleko. I'm a head of software engineering department in Zhytomyr Polytechnic State University, Zhytomyr, Ukraine. I'm pleased to present a report on method of machine learning on the basis of discrete orthogonal polynomials of Chebyshev. Authors Igor Puleko, Svetlana Kravchenko, Viktor Chumakevych, and Vadym Ptashnyk. The report consists of 5 parts: introduction, machine learning regression methods, machine learning approach based on the discrete orthogonal polynomials of Chebyshev, results and discussions, conclusions. Introduction. Lately, machine learning methods have been widely used to solve the market, product, and service prediction problems. Machine learning is the method or artificial intelligence that teaches a computer to solve various applied problems on its own. The purpose of machine learning is to predict the result based on the available input data. The more diverse the input data are, the easier it is for a machine to find some patterns and achieve more accurate results. Machine learning often uses statistical techniques to provide computers with the ability to learn from data without being explicitly programmed. One of these statistical methods is regression. Regression refers to the statistical methods of supervised learning and is based on the classical optimization statistical algorithms. Learning regression methods. Machine learning regression method is primarily intended for numerical prediction the behavior of numerical data. The regression model is the constructed function of independent variable and of coefficients with random variables included. The dependent variable is considered to be described by the sum of the values of the model and by independent variables. According to the nature of the distribution of the dependent variable, we make assumptions called by the hypothesis of the generation of data. To confirm or reject this hypothesis, statistical tests are conducted. Residual analysis is the difference between the values observed and the values predicted by the constructed regression model. It is considered that the dependent variables is free of errors. As the model, polynomials are often used at point quadratic approximation as the polynomial deviation, displayed under number 1. From the given function on the set of points, we take the variable s that is displayed under number 2. To construct an approximation polynomials, we need to choose the coefficients a that the value of s would be minimal. Assumed that l-1 is less or equal. In case of m is equal l-1, the coefficients aj, where j equals to a range from 0, 1 till l-1, can be determined from the system of equations displayed under number 3, where s is equal 0. The solution of the construction problem follows from the minimization of the functional under number 2 and leads to the solution displayed under number 4. The solution from number 4 that in order to construct a regression model, it is necessary to find an inverse matrix. This operation becomes time-consuming when the polynomial degree should be increased. To eliminate this drawback, we suggest a method of construction, the polynomial regression based on Chebyshev orthogonal polynomials. Machine learning approach based on the discrete orthogonal polynomials of Chebyshev. Let P range displayed under number 5 be a given system of polynomials orthogonal on the system of points sum of x, x0, x1 until x l-1, since the polynomials under number 5 are linearly independent and an arbitrary polynomial qmx can be represented as a linear combination of the polynomials from the system 5. And the number 6, this is representation is called the expansion of the polynomials qmx in terms of the system displayed on the number 5. Perform the orthonormation of the system of basis functions. We call the system of functions defined by the system of points of the interval 0 till t as the orthonormal on this interval with the weight p if all the functions of this system satisfy the conditions on the number 7. The condition of the orthonormality of the polynomials pix leads to the x tx equals to e and x. The elements of the matrix have the form located at the bottom of the page. In such a case, the problem of construction a regression model of the function on the set of points orthonormated by the polynomials of the degree m and will be presented as follows under number 8. To solve it, we need to calculate the coefficients according to the formula located under number 9. The approximation polynomials has the form under number 10. Discrete orthonormal Chebyshev polynomials defined on the interval 0 t are given by the formula 11, which allows us to find all Chebyshev polynomials by means of the first two polynomials under number 12. We find the approximation formula for the Chebyshev polynomials under number 13. Based on the formula obtained, the process of the construction the regression model can be presented in the step-by-step form. Step 1. The input data and the maximal degree m of Chebyshev polynomial are inputted. The input data should be taken at regular intervals, and for better prediction, it's advisable that the condition m is way less than L-1 is retained. Step number 2. Chebyshev polynomials of the 0 and 1 orders are calculated according to the formula 12. Step number 3. With the help of the loop operator, a recurrent procedure is implemented in which to reach the highest degree MOF, the polynomial, the following occurs. By the formula 11, the remaining Chebyshev polynomials till the degree m are calculated. The coefficients bi of the polynomial according to the formula 9 are calculated. The approximating polynomial number 13 is formed. Step number 4. For each degree of the polynomial, the sum of squared differences of the input data and the approximated values on the number 2 is calculated. Step number 5. The minimal value of S, which is the optional order of the model 8, is determined. Step number 6. The coefficients of the polynomial model with the optional values of S are chosen as the basis of predictive algorithms are built based on it. Results and discussions. Verification of the correct functioning of the developed method has been carried out on the problem of predicting of the sales of mineral water bottles, 1.5-liter bottles, in the supermarket used MathCAD software and Python. Discussions. Verification of the correct functioning of the developed method has been carried out on the problem of prediction of the sales of mineral water 1.5-liter bottles in the supermarket using MathCAD software and Python. Figure number 2. The machine learning was conducted according to the statistics for 2016, 17, and 19 as training samples, and the incomplete statistics for 2019 were used as validation data. For example, in figure number 3, the data of water sales for each day of 2016 and the obtained approximation by means of the developed methods optional 10th degree polynomial are shown. The refinement of the polynomial coefficients according to the data for 2017 and 18 was provided us with an opportunity to build an optimal model for the prediction of mineral water sales for 2019. Figure number 4. The prediction of water sales carried out for 2019 with continuous training is compared to the partial data available at that time. Figure number 5. In figure number 6, a graph of prediction errors for the available period of data for 2019 is shown. It is seen that over the entire period, except for the first 20 days, the forecast is adequate and the prediction errors are small. Figure number 6. Errors in prediction of mineral water sales for 2019 for the model of continuous training. As can be seen from the graphs presented, a prediction model for the period of available data adequately reflects to the state of sales. As for the first 20 days here, the prediction proved to be not accurate. This is due to the great release of water sales at the beginning of the year, which is probably related to the New Year holidays. Conclusions. The use of the discrete orthogonal polynomials of Chebyshev for machine learning methods has been theoretically substantiated. They conducted investigation on the application of this method to the prediction of the mineral water sales have been confirmed the adequacy of the proposed model of machine learning and allow the effective formatting of regression models for the prediction complex processes. In future, it is planned to carry out a study to determine the optional interval for approximation by means of Chebyshev polynomials and its effect on the terms of prediction. It is also advised to consider multivariable regression analysis. Thank you very much for your attention.